speaker, CRDs, Custom Resource Definition of Kubernetes. So please show of hands, how do you rate yourself, beginner or expert in Kubernetes? Let's look at the beginners first. No discrimination, no judgment here. Thank you so much. Okay, very good, quite a good number. And then next, who are self-proclaimed experts? Oh, you guys are too humble and too modest. But anyway, everybody's a beginner. When in this industry, we got to be, it's always day one. Yeah, you got to treat yourself like someone in day one, studying and, absorbing the concepts of new technology. But no, not new, but quite an interesting one. So why do I put dinosaurs over here? So, kids get, sorry, is there a question over there? Oh, sorry, it's all right. So kids get baffled and amused. We got different types of dinosaurs, right? Okay. And same with Kubernetes. I'm not saying Kubernetes, hello, I'm not saying Kubernetes is some kind of dinosaur. It is not, far from it, actually. But in Kubernetes, you have different types or kinds of objects, okay? So here, for my next slide, I want to tickle your brain and ask you, what is this Kubernetes YAML about, guys? I'm asking for participants and volunteers. Please, guys. Anyone who's going to raise their hand? You see over here a kind. Yes, sir, please. I really appreciate you raising your hand. All right. Cool. Thank you so much, guys. Good, good, good. All right. So what specifically does this YAML do? It's a pod. Okay. Number two, kind pod. What does it do? Spec containers. Line number 8, image, busy box. What does it do?
It's a shark. It's not a dinosaur.
Yeah, not a dinosaur. Very good. Okay. But it instantiates a pod using an image open source busy box and runs command. Okay, executes command sleep, 3,600 seconds, it dies. All right, image pull policy always, because okay. So my point is, it's a kind pod. It's one of those dinosaurs, okay? Next, what is this, guys? What kind of YAML is this? Okay, Sir Vince over here, what's up?
It's a deployment.
Okay, very good. What specifically does the deployment do in this case? Okay, you have a kind deployment, okay? It creates how many replicas? 3, right? Thank you so much. And what does it do? It uses whatever you bake here in your image, it uses that image. Ooh, very flattering image, exposes to container port 8080. I mean, at least exposes that. The services are very different. Okay, cool. Oh, share screen. Okay. And then let's go to more specific stuff. Okay, what kind of YAML is this, guys? Don't sleep on me yet, guys. I'm segueing into the real meat of the discussion. What is this? Line number 2, kind, colon, cluster config. What does it do, guys? We're in the building of the #1 public cloud provider in the world. Yeah, very good guess, sir. Okay, for all of us, for all of us familiar with EKS, Elastic Kubernetes Service of AWS, you need a cluster config YAML to instantiate an EKS cluster. Okay, very good. Thank you very, very much for sharing your familiarity with this. And what is this? Okay, this is going to be the last. Okay, external secret. What kind of YAML is this, guys? Okay, I want to segue here. I want to introduce to you this kind external secret because it's one of those kinds why I want to discuss this topic with you. Kind external secret, okay? Kind external secret is not your native Kubernetes object. If you've tried to spin up your vanilla, let's say vanilla, cloud agnostic, vanilla Kubernetes cluster, okay, you won't find this, guys. The familiar ones, you have a pod, basic unit of deployment of Kubernetes, you have a deployment, replica set, service, ingress, whatever, but you won't find an example like this. Because these guys, this kind, external secret and others like this, is called a custom resource, okay? It's customized, okay? So how it's like making your own dinosaur, Okay, it's like Jurassic Park in the past 10 years where they kind of genetically modified something and created their own dinosaur. You could do the same in Kubernetes, by the way. Okay, all right. So how do we make one, guys? So I've introduced you different kinds of dinosaurs, and one of them in the lower right is a very customized kind of dinosaurs. So why would you want to create your own kind of dinosaur? There are actually some factors here. Number one, you know why we use YAML for instantiating cube objects, right? Because you want to offer, Kubernetes, you see Kubernetes something like a Lego blocks, a platform where you could instantiate objects as yellow blocks connecting to each other, call their own APIs, right? So here, okay, when you instantiate a native Kubernetes object, you're actually offering customizability. Okay, you see the pod a while ago. You can customize stuff how to do spec, container, everything. Okay, but here, what if you want to productize your own, okay, your own cube object? Here is where you can use CRDs. Okay, for example, what if you want to limit the functionalities of default? You're limited of the functionalities of default cube objects, for example. Okay, and you need a faithful cube object solution. What if? Okay, guys, you're a software engineer. Okay, maybe full stack. Okay, you deploy stuff into production and you get pissed off when your operations customize, the YAML after you released it already. Okay, doesn't that piss you off? Because, oh, come on, we already have prod values and somebody customized it for prod that's not approved. Okay, so you could lock in that configuration, okay, by, I'm not anti-customizability, but I'm actually for locking releases. That's why we have CRDs, okay? And last example, you could have custom cluster objects. For example, who has worked with ingress controllers before, guys? Concept of ingress in AWS, okay? So it's a large topic. So to deploy an ingress, okay, to expose an application through an ingress, you need ingress controller, you need an ingress concept, you need an ingress class. You get messed up if they don't have the same metadata, right? Okay. So how do you deploy them as one? You need a CRD. You can make a custom CRD. You go back to your companies tomorrow and say, hey, guys, I learned about CRDs. We can avoid these types of problems. Okay. So before I bore you with stuff, I'm going to bore you more. I'm going to show you how it's done, guys. Okay. See, to create your own custom resource. For example, have you heard of the cube kind, YAML kind called, what is this? Cron, right? I think Coach Vince over there is one of my cube mentors at the back. He's wearing pink over there. He introduced me kind cron, okay, where you can actually, instead of using a cron from the CLI and Linux, actually, you can use a cube, a cube object called kind cron, and there's some definitions over there. But what if you want to customize your own cron to automatically use a custom object, okay? So here's how it's done. Imagine you need a custom resource, a time logger. For example, you need to instantiate a cron that instantiates an image that says hello world every 5 seconds, for example. That's so customized, right? So before you make that, you put your custom time logger in a function, Dockerize it, push it to Docker Hub or whatever. Maybe you have Artifactory back in your offices or back in your organizations. And then at the same time, you need to instantiate your own controller. That is how messy it is. That's why when you go back and want to propose this in your organizations, you need a lot of CI/CD for this one. And that's a great project. I mean, that's a great headspace project or proposal for you guys. Okay. So for example, you put your function over here and instantiate it using a custom resource and a custom resource controller and CR controller. You Dockerize it also. So here, let me just show you, for example, what I'm going to show you is this one. Okay, this lower box over here, I instantiated my own custom resource definition. I'm still connected to my own Q cluster over here. Okay, still connect over there. So I have a time cron job example. And how did I build it? Okay, I built it, for example, if you can just focus on me and not get messed up with your views. Imagine this is your time logger, okay? And I have this Docker file. That's the upper right box I've been telling you. Okay, so you have a Docker file that bakes this simple logic over here on the right. Okay, it just outputs every 1,000 milliseconds. Is it yeah, every 1,000 milliseconds in TypeScript. Every 1,000 milliseconds time. Okay, console that time to local string time. Time is now, time is not hello world. Okay, I bake it. Okay, push it into my sorry. Ooh, my God, that's not right. Push it. Oh, I was looking at your LinkedIn, man. Yeah. Yeah. You see this time, the time. You know, my folks are here in my office, so they can laugh and watch it. Anyway. Okay, so I push my own, Docker image, okay, because I want it to be used. And at the same time, I have a separate Docker image for the controller. There's a lower right box over there in the diagram, okay. So before you instantiate this, okay, you need another, okay, project which you deploy into your cluster, okay, that handles, the controller. It's a little bit more complicated than it sounds, okay? I tried to design it for a large audience, but I will show you Golang. Okay, oh my God, Golang. Okay, so this is where, oh, that's a nice pause. Give me a moment, guys. I want to give you the larger gist. Okay, see, this is the reason why if you want to go deep into cluster development Kubernetes, you really have to know Golang. Okay, imagine Kubernetes, each object is called by an API. It's like an API endpoint, and the cluster has a series of API endpoints and stuff. Okay, imagine each controller object is like a Golang microservice. Okay, so it's like making your own Golang controller microservice. Okay, so you make this, that's the API handler, and down here, okay, and down here, over here, it's in config, sorry, the controller itself. Okay, this is where it handles and has instructions to deploy. You see this one? My time logger. Okay, so put it simply. Okay, let's go back to the presentation. Okay, what you see, the first project is this one. The second project is this one. Okay, and then you instantiate it and apply your time logger. Okay, so let's go back to how I applied my time logger over here. Okay, this is the actual, this is the actual, time cron job. Okay, this time cron job is my custom resource. You will not find it in any native cluster because I made it, okay, using the two boxes a while ago. I made my own logic. Okay, I made my own API handler controller. I can make this. Right? So you see the nitty-gritty of how to operationalize it back in your organization. So you need to be some kind of a Kubernetes cluster developer using Golang. Okay, I'm not saying it's that simple. I'm not saying you shouldn't do it, but it's a good thing to start with when you want to, leverage the potential of cluster development Kubernetes. Okay. Hope did not confuse you. That any question? I'm sensing that folks looking at me have burning questions. Please, guys, I'm here. Questions, guys? I think my time's up 20 seconds. I'm 20 minutes, so please take advantage while I'm here. Yes, Chris. Okay, there's a lot of question and answer. Okay. Okay. Sorry. Thank you. I'll hand over the Q&A part to Chris. And thank you for listening. I hope I did it for you with that quite technical talk. But thank you. Happy here.
Thank you for that, man. So, we saw how all those nitty-gritty stuffs were abstracted using one single YAML file. Honestly, even me, before this event, I don't understand how CRDs work. So I just consume Kubernetes directly, the custom resource definitions. But with that brilliant analogies that Melvin gave me a great idea of how these stuff are done in the background. So if you guys have any questions for Melvin, we have space for around 2 to 3 questions. So please raise your hand and we'll give you a mic. It doesn't necessarily have to be about hardcore CRDs. You can ask anything about Kubernetes, and I'm sure Melvin will be glad to answer that.
What practical application can we use this technology with?
Thank you so much for raising that question. Okay, cool. I want to delve into how engineers compared custom resource definitions with other packaging and templating and release tooling for Kubernetes. If you guys are familiar with Helm charts, okay, if you ask anyone in the open source Kubernetes community, how do you release a bunch of YAMLs, okay, as one deployable release unit? You use Helm. They will always recommend that. In the same vein, you can do this multiple YAMLs, okay, bunched together, and you want them released all at the same time. Okay. The thing is, okay, I'm explaining this as a comparison. In Helm charts, you have all the freedom to customize the inputs as variables, okay, and Helm variables. In CRDs, you want to lock them. Okay, you give no room for mistakes of misconfiguration. Okay. So yeah, to quickly answer the question, you want to bunch a number of Helm files without inviting any human error for misconfiguration. You use CRDs. Right, next question, please. All right, guys. Next question. Oh, please, yes, sir. Thank you.
You mentioned that CRDs are custom, not exactly built in Kubernetes.
That is fine.
How will your cluster know that it's a custom one? Do you import it? How exactly do you do that?
Great question. Okay, any questions? But no question is too small for that. Thank you so much, sir. Okay, that's the purpose of the controller. Okay, you see the diagram I showed, the last diagram I showed for my VS Code. Before you instantiate your custom resource, you need two things: the logic, the function of your custom resource, and your custom resource controller. Okay. The custom resource controller, you can define, okay, the behavior of your custom resource. If it will, use a base image, which is from the stock box. Yeah, okay. So here's the thing, it's kind of easier than it sounds, and I kind of struggle to explain it for an audience like that, for a large audience like this, but I'll never not here. Yeah. To be able to have it recognized by the cluster, you need to have a controller running on your cluster. Okay, internally. Okay, that's why I'm advising, if you go back to your companies, you wanna propose this with your CTO or your principal DevOps or principal software engineers. You have to propose it. You want to maintain your own cluster. Sorry, your own controller in that cluster. Yeah. Thank you, sir. Great. One more question. Okay. Okay, one last question. Thank you, sir. Christian. Oh, sir, please.
Hello, good evening. What are the use cases of this CRD? And can we pass an argument or parameter in the YAML?
Okay, very good. Okay. Sige, for the final question. Okay, I kind of touched base about, this is a better mic. I love this. Okay, hindi na ako nalalag. Okay, this is, I kind of touched base of comparing Helm charts and CRDs, right? Okay, where in Helm charts, it handles best to values.yaml file and bunch of, propagates it through your templates folder and stuff. Okay, sige. One really good use case I've seen CRD happen is that, just like what I mentioned, ingress controllers. So messy, okay. You have ingress controllers by default that are deployed. Ooh, echo alien. Okay. You got ingress controllers by default deployed almost adjacent. You can separate the goes to default, goes to the other namespaces. But if someone in the prod team, for example, or a full stack developer deploys with exactly the same default configurations, okay, it steals traffic, for example.
if you have a CRD that deploys custom ingress controllers with custom ingress classes and custom ingresses, okay, you would avoid that. So here, you with CRDs, the best use case is that you can propose this because it enforces uniqueness. It's so unique. Okay, just like my time logger, I would say that's Melvin's time logger, but it became Melvin's way. I locked it that way. Thank you so much. All right, those questions we have. Thank you, sir.
Thank you, Mels, for that. Okay. So, just a brief commercial before our next speaker. I would like to call our first Kubestronaut from the Philippines. He's from here. So here is Romar Cablao from Central Works, Senior DevOps Engineer, AWS Community Builder, and our first Kubestronaut.
All right, so thank you for that intro, right? So, hello guys, hello everyone. So, by the way, thank you for attending this session or this event. Of course, I've seen some familiar faces in here. Some of you, for sure, I have worked on, especially on those sides. So, for those who knows me, hello. So, this is just a brief commercial. So, before I hand you down to the next speaker, so what I wanted to do now is to just discuss to you what this program is all about, right? So, thank you. So next slide, please. All right, so maybe you can start with that one. Next one, please. All right, so primarily what this program is all about is to basically recognize community leaders as well as those people who constantly improves their knowledge and understanding, not just about Kubernetes, but also the cloud native space in general, right? So hopefully we get to see more people coming into, of course, or getting into this program. So next slide, please. Basically, as mentioned by Ms. K earlier, right? So for you to be able to get into the program, all you just have to do is to complete these 5 certifications in here. So 3 of which are actually performance-based exam. So basically, what's good in this kind of exam is that when you sit on the actual exam, you'll be working on a Linux environment, and then this Linux environment is connected to different clusters, and you have to complete all of the requirements for you to be able to ace the exam. So basically, there are also 2 additional exams that are multiple choice. So if you are starting exploring this field, maybe you can start with Kubernetes and Cloud Native Associate, or maybe Kubernetes and Cloud Native Security Associate for you to get started with. So next slide, please. There you go. So you might be asking, what are the perks and benefits when I get into this program? So first is, of course, you'll get to have some kind of AWS Golden Jacket, similar perks here in Kubestronaut program. So you get to have the Kubernetes Blue Jacket, aka Kubestronaut Jacket. And as part of the program, you'll be receiving a credit badge, right? And then second bullet point in here is that you'll get to have an access to the dedicated Kubernetes or Kubestronaut Slack channel. You'll also get to have vouchers or discounts for your next certification exams. And not just that, you'll also get to have discounts on events that are held under CNCF. And then the last bullet points in here is that when you get into the program, you also get to network with like-minded people as well as those that are part or that are domain expert in the cloud native computing foundation landscape. So next slide, please. There you go. So I haven't mentioned yet, so this program is actually supported by the Cloud Native Computing Foundation and the Linux Foundation, basically. And there's a dedicated page for the Kubestronaut program. So in this slide, the one that you're seeing on the screen, these are the this is the map where you would see the list of people or individuals who are certified and are part of the Kubestronaut program. So next slide, please. There you go. So how can you get started? Of course, thank you for our sponsor, Code Cloud. So Code Cloud basically has a lot of training materials for you to get started with. And if you wanted to start learning about containers, you can freely subscribe to Code Cloud and take the Docker for absolute beginner. It's all for free. You can take the training materials, and if you're happy with the tool, or if you feel like you're really interested with other training materials that they can offer, you can try out as well with Code Cloud and take the learning path for you to be able to take some other certifications that are related to Kubernetes. So next slide, please. All right. So I've also created a page in which I put all of my notes in relation with the certifications, right? So if you will be asking me what's my recommendation in terms of how you're gonna take the certification, of course, it's still better to start with the foundational ones, right? Those that are on the left side of your screen. So basically, Kubernetes and Cloud Native Associate, Kubernetes and Cloud Native Security Associate, and such. And then once you get to have the idea and the feels of getting or knowing about the cloud native space, I suggest as well to take hands-on experience by, of course, having or exploring Kubernetes firsthand. And then you might want to also take some other certifications that are performance-based, right? So once you get all of these 5 certifications, automatically you'll get into the Kubestronaut program. So slide, please. And if you wanted to learn more about Kubestronaut, you can basically visit the CNCF page, and you may also connect or chat with me later on. So I think that's it. Thank you. Heading back to our
Thanks, Romar. So we have one question from the audience.
So is the exam similar exam that we have to take with the examination centers, and how much is the cost per exam?
All right. So basically, you can take the certifications online. So as long as you have a good internet connection, you have a laptop that you can make use of, or device or any machines, then basically you can take the certification. In terms of the price, it's roughly $395, if I'm not mistaken. So roughly in that kind of level, right? So I think 15K for the performance exam, if I'm not mistaken. Yeah. In terms of the expiration, CNCF recently changed their policy. Before, the expiration would take around 3 years, but now they enforce the 2 years expiration for the certifications. Yeah, Kubestronaut also expire if one of your certification expire. So you have to maintain or recertify for you to be able to continue being part of the program. But what's good with CNCF certification is that when you buy one or when you purchase one, automatically you'll get to have a one free retake. So at least there's a safety net if you would like to try and test taking their certifications.
Okay, if there's no more questions. We're proceeding with our last speaker for tonight. Our next speaker is an AWS Principal EC2 Graviton Solutions Architect. He's a Principal EC2 Graviton Solution Architect at AWS. He enables customers and partners with best practices surrounding their workloads and efficient compute, including Kubernetes. So
is actually quite a mouthful, right? So basically what it means is that within EC2, there are many features, there are many specialization. Like for example, you have the auto scaling group, you have the Nitro enclaves, for example, for confidential compute, there's spot instances to reduce costs. But for me, I specialize in the ARM64 based processor, which is Graviton. So I'm just curious, like, who in this room has heard of Graviton and have actually tried them out? Okay, a few hands, right? Okay, so I think a large number of you have not heard of try it before. So I will do a level set and introduce to you what this is about, all right? Yeah, so for a start, I would like to share with you some statistics. So what happened is that the Datadog, one of our vendor, right, and a very popular 80% of their AWS customers are actually using ARM64 processors, right? Which is the Graviton processors when they use AWS. And there's tremendous growth. So a year ago, it was actually 9% of their spend. And a year later is 18%, right? So that's quite a lot of growth over there. So why is it that our processors are getting adoption, right? It's because there's a broad ecosystem support nowadays, right? So you can see that many of the CNCF projects nowadays have started supporting ARM in addition to x86. So when they publish their containers and make it available on, say, Docker Hub, it will be available in what we call multi-architecture, right? It means that they support both x86 as well as ARM64 processors. So one of the popular ones that most people have asked me about is the Istio, right? Service mesh. So some of you may be familiar with service mesh, right? So Istio, actually 2 years back, they didn't have ARM support, right? But because many of their consumers and the community have asked them for this support, and what they did was that their main blocker back then was that their pipeline too didn't have the ARM servers, so they went out there to get some of these ARM servers available so that they can start building container images natively on ARM and make it available, right? So as of last year, they have already start supporting multi-architecture as well. And we are not the only manufacturer of ARM processors, right? So for consumers like you, if you are using your own personal laptop at home, some of you may have bought like the Apple Silicon laptops, right? Like the M1, M2, M3, and they have just announced M4. So why do I mention Apple Silicon is because they also made that transition from Intel processor to ARM processors as well. And the reason is that ARM processors consume very little energy, right? And that's why we are also using ARM processors in our mobile phones today. And in AWS, we actually use the blueprint that comes from ARM, the company, and we are a manufacturer of their blueprint and design, right? But there are many other manufacturers that have followed our leadership and joined onto the bandwagon as well, right? So you can see that Ali Cloud, Huawei with their Kunpeng chip, and then Azure, if you're on Azure and Google, right, they will be using the ARM processors from Ampere Ultra So Ampere Ultra specializes in manufacturing ARM processors for on-prem data centers. So if you have a data center today, you can actually buy ARM servers from Ampere Ultra. Okay, but since end of last year, Google and Azure, they have actually announced that they will also start manufacturing ARM processor moving on with their Cobalt and the Google Cloud as well. They will also start manufacturing them. But I will drill down into the Graviton processors because we have quite a few generations, right? Since we start launching it like almost 5 to 6 years ago, right? So we started with Graviton 1, but nowadays we don't really share about it anymore because we have Graviton 2, which is widely available. So if you are making use of the Singapore region, right? Graviton 2 and 3 are already available in the Singapore region. In the newly launched Malaysia region, we have it as well. And in our up-and-coming Thailand region, it will also be available as well. So Graviton processors are going to be available in most of our regions. And you can see that the key business benefit, and this has led to the popularity of Graviton processors, right, is that it actually brings you a lot of the cost savings, right? So if you look at the on-demand price and compare the price of Graviton versus the Intel processors, you actually see that we are actually 20% cheaper. And then you can get up to 20% improvement in the performance as well. So overall, you add the 20 to the 20 and you get 40% in terms of the improvement in price performance. And that's a lot, right? In today's climate, right? That's almost half of your infrastructure costs, right? And that's a lot of savings that you can help your company to actually save when you are running Kubernetes workloads. And you can also see 2 years later, we follow up with Graviton 3 processors that brings about 25% better performance. And 25% is the ballpark that we are trying to bring with every new generation. And with Graviton 4, we did it even better with 30% better performance and also more vCPU that's available in a single EC2 as well. So how do I identify these EC2 types, right? So you can see that for these EC2 types, they are ending with the suffix G, right? So you know by now that when you have suffix A is for AMD, then I for Intel, and when you have G, it indicates that they are Graviton processors. So we have the CMR family, just like the x86 instances. We also have a instance type that actually comes with a GPU, right? So we have a NVIDIA T4G GPU that comes with the G5G instance. I know many of you are running Gen AI workloads and trying to bring the Gen AI workloads in your testing environment. So G5G is something that you can consider for AI/ML inferencing. And it's very cheap, especially if you're running on spot today, right? So what is the best way to go about trying out Graviton, right? So if you go back and you want to a low-cost way of trying it out, it will be the T4G instances, right? And if you run T4G on spot, that is the lowest cost that you can get if you want to try out Graviton instance. Right, so T4G is a burstable instance. It's lightweight, but good enough if you want to just do some functional testing. So I talk about the performance elements, right? Why is it that we can actually perform better? Now, in a processor, if you know the processor architecture, there are many variables at play, right? There's the frequency, there is the amount of cache that comes in the processor. But what's also important is that how many physical cores do you actually have to power those vCPUs? So in a typical x86 processor, they will be running hyper-threading, right? So two vCPUs will be backed up by one physical core. Now, the reason why Intel introduces that is because they recognize that your program will not be busy all the time. So if that's the case, then they can just share the physical core, right? So that way, the physical core doesn't get wasted and you'll be fully utilized. But however, if your program is very busy, and what will happen is that they still share the same physical core, and then that resource contention will result in the deterioration of performance. So it will actually increase the latency of your application, right? If you run your vCPU at the maximum utilization. And so for Graviton instance, we don't run this hyper-threading or SMT, right? So each vCPU is backed by a physical core. So not only are they like 20% cheaper, we also give you double the amount of physical cores that you get with each EC2, right? So that way they will have isolated and dedicated access to their physical core, and they don't have to do any contention, right, for the resource. So what typically happens is that when you actually run a load test on an EC2, right? Over here, imagine I'm running a load test on an EC2. There is a CPU utilization, and there's also the application latency. So for a start, you will see that the x86 and Graviton will actually perform almost similarly, right? They have maintained the latency as you increase the load, but only up to a certain point in time. So at the 50 to 60% mark, hyper-threading starts to kick in, and the resource contention that I mentioned start to kick in, and the latency will deteriorate, right? So that is why most of you who are running horizontal port autoscaler, you will actually be scaling out at the 50 to 60% mark, right? But with Graviton, when you run the HPA, you can actually increase that threshold to 80% or even 90%. And when you do that, you actually unlock this shaded area, which is the unlocked capacity. So what does that actually mean? It means that instead of running 5 ports inside x86, right? With Graviton, you can actually end up just running 4 ports to serve the same number of requests, right? So that's the element of the 20% performance improvement that I was talking about. And in the later slides, I'll be sharing some of the best practices when you onboard Graviton. And one of the best practices is that the more recent software that you run, the better, right? So for those of you who are still on Java 8, right, it's out of support and it's not secured anymore. It's not supported by the community. So upgrade it to Java 11, or even better, it will be Java 17, right, which will be more optimized for ARM64. And this applies to your operating system as well. So if you are still on Amazon Linux 2, my recommendation is that upgrade to AWS Amazon Linux 2023, which will be better optimized for Graviton as well. So how do I create an image that I can run on ARM64 Graviton processors, right? So the first concept that you will need to know is the multi-architecture manifest list, right? So we will create a multi-architecture Docker image instead of x86 Docker image. So today, when you run your build, you'll usually be creating just one Docker image. So in order to get it to be supported on ARM, we'll be creating the ARM64 V8 image as well. And then in addition, we create a metadata file where the format is a JSON file. And we call this JSON file the manifest list. So this manifest list actually reference two images. So you reference the ARM image, you also reference the x86 image. But why do we want to actually create this multi-architecture image, right? It's just so that we can continue to use the same image name and the image tag. And when we deploy this image name and image tag, we don't have to specify, hey, I want to use the x86 image, or I want to use the ARM64 image. I just have to give the same image name and tag, just like what I'm doing today. And the container engine, which is a container D runtime, will make that decision for you. So if it gets deployed on x86 host, it will download the corresponding x86 image. If it gets deployed on the Graviton server, you will download the ARM64 image. So it becomes transparent to the application team who is creating the deployment file. Oops. Okay. So for those of you who wants to try out this creation of this multi-architecture, what's the easiest way to do that, right? So Docker, the company, they created this tool called Docker Build X, right? That allows you to create a multi-architecture file. So if you are running an x86 laptop today, right, you can make use of Docker Build X to create an ARM image, right? So you just have to specify the platform, AMD, as well as ARM64, and create the multi-architecture image and manifest file using just one single command. So it's very convenient. But for those of you who are running the Apple M1, M2 laptops, right, the reverse is the same as well, right? So you will be able to emulate x86 for you and convert those ARM instructions to x86 instruction set, right? And using one command, you can also create the multi-architecture manifest file. But because it's so convenient, there's always trade-offs, right? So the trade-off is that because it runs emulation, so it will take more time because it needs to convert from one instruction set to another instruction set. And that conversion will take time. So that's why you can see that I highlighted this as an anti-practice. So it's good for trying out, but don't do this in production. Okay. So what should you be doing in production? You should actually be adjusting your pipeline tool, whether it's a GitLab or a Circle CI, or whether you're using Jenkins today. You can adjust your pipeline to look somewhat like this. So instead of just building for Intel and x86, I will run a parallel stage to actually build for ARM as well. And then also finally add a stage that creates the manifest list. And I'll be pushing all these three artifacts into the registry, into a Docker registry. And these three artifacts will form your multi-architecture manifest list, right? And for those of you who are more advanced, right, I recognize that some of you are running the pipeline inside Kubernetes itself, right? And that's a good thing to do because you are saving costs when no jobs are actually running, right? And Kubernetes will then scale the pods when the jobs are running. So what you can do is that when you try to build Docker image inside a Kubernetes environment, you are essentially doing what we call a Docker in Docker build. But that Docker in Docker build comes with some security exposure. It can be slower as well. So as a best practice, we advocate you to use tools such as Kaneko, Builder, Podman, BuildKit, and all these tools actually will do the container build without the need for container daemon, right? So you don't have to install that Docker daemon anymore, and that will minimize the security exposure. So what are some of the other considerations? So you may be thinking, hey, maybe I have to, in order to use ARM, I have to start changing some code in my program. I may be doing some changes in my Docker file as well. That's certainly not the case, right? So I have worked with more than 100 customers across ASEAN, and 99% of the time, there's no code changes needed. And in the remaining 1% of the time, you may have to upgrade some of the older libraries with the newer versions, right? So there's very little code change that's needed. And the same goes for the Docker file as well. So in the Docker file instruction set, typically you don't have to do any changes. But if, let's say, you want to optimize the build of this Docker file, and maybe if you have binaries that are x86 specific and you want to build for ARM64 inside the Docker file, you can make use of the Docker variables such as like target OS and target architecture, as you see in this Docker file. So this is a Docker file that actually uses the Golang language. And you can see that we are following best practices in the Docker file over here, right? So there's the build stage. And after the binary is built, then I proceed to the run stage to actually run the application. But in the build stage, I recognize that I have to build for x86 and I have to build cross-compile for ARM64 as well. So by inserting these variables, right, the build will actually deduplicate the steps and optimize the steps such that it produces both binary and optimize the time by doing the deduplication. Okay, and more on the CI/CD tools, I recognize that some of you may be using some runners that are actually hosted together on the cloud with the CI/CD tools that you are using. For example, GitLab CI, you can maybe using some of the hosted runners. But the good news is that most of these cloud tools, right, pipeline tools, they already have the ARM runners that's ready. So you can actually build ARM container image by you making use of these ARM runners. So the only exception is Bitbucket pipeline, which at the moment does not have hosted ARM runners yet. So you will have to use self-hosted runners, whether it's on-prem VMs or our EC2 on AWS. Okay, so now that we have gone through the assessment, the programming languages, and some of the best practices, you can see that you may be thinking about deployment and setting up of your cluster. So if you are new to this kind of setup, recognize that actually inside the same Kubernetes cluster, whether you are using GKE or EKS or AKE, right? AKS, so they have the ability to have mixed architecture node groups, right? So you can bring up ARM node group running in parallel and under the same cluster in addition to your x86 node groups. And when you have two node groups, right, your best practice will be to start to target the deployment. So that can be certain applications that are already multi-architecture, then they can go either to the x86 node group or ARM node group or both at the same time. But there could be certain third-party application that isn't ready yet, right? It's not certified for ARM yet, and that's fine as well. And what you can do is you can make use of node selectors, right? Which is a Kubernetes construct to actually select the x86 architecture so that those pods will always go there. And if you don't like node selectors, you can also have control and final control with like tails and tolerations, and also node affinity will also work as well. Okay. The other thing that I would like to introduce you is actually that of Carpenter. How many people in this room already know about Carpenter and are using Carpenter? Okay, so most of you, I think I've spoken to some customers earlier, so I know they really know Carpenter, but most of you do not know Carpenter yet, right? So if it is fine, but I'm sure you know about cluster autoscaler, right? So most of you will be using cluster autoscaler to scale your node groups today. Now, in AWS, we actually went back to the drawing board like 3 years ago, and we think about, hey, a lot of customers have been telling us that cluster autoscaler does not really work well for them. They are facing a lot of latency. So how can they improve the time to provisioning, right? So we went back to the drawing board and we say, hey, why not we reinvent this experience and come up with a new tool. And that new tool is Carpenter. So how does Carpenter work, right? Essentially what you do is when you have pending pods, the Kubernetes scheduler will check whether there's existing capacity. If there is, it will make use of the existing capacity. But however, if it doesn't have those capacity, then Carpenter will know that, hey, there's unschedulable pods. And now I need to make the compute. I need to spin up new EC2 to increase the number of compute capacity that I have. So what I'll do is Carpenter will then directly call the EC2 fleet API, and you also do bin packing and right sizing while bringing up these nodes. What I mean is that if you need 3 vCPU in total, like maybe you have 3 pods and each pod need 1 vCPU, a total of 3 vCPU, you will actually bring up just an X large machine, right, with some additional capacity to host the daemon sets, right? So that compute is a right size compute. And you also have the ability to do what we call consolidation. So over time, your cluster will have gaps, right? As you do scale up, scale down, deployment, or you can remove the deployment, delete the deployment. So there will be gaps, just like storage defragmentation and memory defragmentation. Carpenter is also doing what we call a kind of a defragmentation, but we call it consolidation, right? So it consolidates all these EC2 nodes that has gaps and put it into a right size instance again, right? And that ties in very well with the Graviton. Graviton helps you to reduce the cost of the infrastructure, and the same goes for Carpenter as well, right? So I will encourage you to know more about Carpenter and try it out, right? So you can see how I can actually reduce the maintenance overhead with Carpenter as well. So when I actually want to make use of ARM and Graviton inside my EKS cluster, I have to create another node group, right? And because cluster autoscaler says that I need to uniform the EC2 to be uniform in terms of the CPU and memory ratio. So if I want to additional types, I have to create new node groups. And these node groups are each backed by an auto-scaling group. So there's node groups, there's auto-scaling groups, there's cluster auto-scaler configuration. So there's too much complexity, right? And there's a lot of overhead if I want to maintain all these. But with Carpenter, we remove all those operational complexity, and then with just a few lines of YAML file declarative code, right? I can actually do what the cluster autoscaler is doing. So it's something that is easy to configure and troubleshoot as well. And the other release best practice that I have when it comes to deployment, I actually learned about this from a customer, right? That's in Malaysia. So what's happening is that they actually make use of customize when they are adopting Carpenter and also Graviton. So they have a x86 deployment file over there, right? So it's a normal deployment file that they deploy to x86. But they make use of customize. And you know that customize is something, it's a feature in Kubernetes that you can make use of. It actually creates resources based on other sources, right? So I have a x86 deployment as a source. And then I say, I will create a Graviton component. And what that component will do is that it will inject the load selector to select ARM64 instances, right? So whenever I want to migrate this microservice to Graviton ARM server, I will just add this patch into the deployment environment. So in the development environment, I will say this patch.yaml is actually making use of the Graviton patch component, which will put this Graviton layer on top of the x86 deployment. So that means I can transit the deployment from x86 to ARM64 without editing the original deployment file. And this deployment approach also makes it transparent to the application team as well, right? So the application team doesn't have to know that they are already moving on to a ARM64 instance, right? They still check in the same deployment file to the gig, and then the platform team will then add on the customized component for them. And a few other release best practice is that I'm not going to ask you to migrate to Graviton in one big bang, right? That's certainly not the recommendation that we want to make today. So when you adopt any migration project, right? And Graviton migration is just like any migration project that you are taking on today. So in any migration project, we want to do a canary release, right? So we can introduce like 1 to 2 servers of Graviton running alongside the x86 for a start. And then I will monitor how stable it is, how robust it is the performance good enough for me? And if everything is okay, then I will migrate more and more traffic over the next few weeks, and eventually I can actually sunset the x86 instances, all right? Cool. So I'm going to, in the next few minutes, I'm going to do some demos, right? And one of the demo that I like to do on the performance, to demonstrate the performance elements, right, is on Lambda. So actually we use Graviton to power many of the managed services. So your Elasticache, your OpenSearch, your EMR, for example, and even Lambda can actually run on Graviton, right? And it's easy to do so. And in Lambda, what I can actually do is, like what I mentioned, right? I can do a canary release. I can say, hey, this Lambda will distribute 50% of the request to x86, and the other 50% to a Lambda version that's running on ARM64. Okay, so I'm going to execute that now. Let me do that. Okay, so I have created a microservice that actually generates prime numbers, right? So you can see that it's compute intensive for sure. So it takes some time for the request to come back. So these are just a few requests. And you can actually see the response that is coming back, right? So what do you see in the response, right? You see ARM64. ARM64 is another industry terms for ARM64. Okay, so if you see some of these varying terms, it all means the same thing. And the same goes for x86. AMD64 is equivalent of x86, and then some people like to call it x64 as well. Right, so you can see some requests going to ARM64, some requests going to x86. But besides the architecture difference, right, what else do you notice? Yeah, the elapsed time, right? So you can actually see that, hey, the elapsed time for ARM is actually lesser than the elapsed time for x86, right? Yeah, so you can actually see that when you run Lambda on Graviton, right, behind the scene, it is always a Graviton 2 instance. So there's consistency in the performance and it has better performance as well. When you actually run Lambda on x86, you may actually land on the older hardware, right? Because we manage this hardware and we want to reuse this hardware, you may actually land on some of this older hardware. And so compared to the latest Graviton instances, they will have poorer performance. Cool. All right. So besides this demo, maybe I will also show you this. So basically, I have created this deployment file, right? And what it's actually doing is that it's actually deploying a microservice that does a Monte Carlo calculation, right? I was doing this with a POC with a bank, right? So they are actually pricing the portfolio for their traders. And you can see that I am actually targeting the C7G. So I want to deploy to a Graviton 3 instance. C7G is a Graviton 3. And then I'm pulling down the image from this public ECR, right? So let's take a look at the existing nodes that I have. Okay, so I'm running my Cube system in Fargate, by the way. So you can see these Fargate nodes. And you can also see that I already have 2 existing nodes where I have deployed some application already, right? So let's take a look at the pods that I have, right? So I have a few pods that's already running, running some Olama, which I will demo later as well. Right, but what I want to do now is I'm going to apply and deploy this microservice. Right. Okay, so it's deployed. Okay, so remember that at the moment I don't have the compute that's ready for these pods, right? So let's see how long we actually get to deploy these pods, right? So the pricing.arm, I actually want 2 replicas. Okay, so I'm just going to keep calling the command because I don't have watch on my Mac OS. Okay. So it has taken 40 minutes. So it has downloaded the image and it's creating the container now, right? So 51 seconds, 54 seconds. Okay, so we're going to keep going until it's running and see how long it actually takes to provision. Okay, so about 70 seconds, right? So it's about a minute. Yeah, so that's the promise of Carpenter, right? So within a minute, it's actually able to provision the EC2, download the container, and bring the container up and running, right? So that's the kind of provisioning latency that we are trying to minimize. So when you run it with cluster autoscaler, this can take anything from like 6 to 10 minutes, right? But with Carpenter, we are shortening that provisioning speed. So let's take a look at the EC2 console. Oops. So let's log in again. Yeah, so we can see that the C7G, right? So that's the one that has been provisioned to accommodate that 2 ports, right? But I'm also running some other nodes, right? So you can see there's this R7.4x large. There's quite a lot of memory that I'm running. And what am I hosting, right? So it's also a Graviton server, right? And what I'm hosting on it is actually my own private Gen AI tool, right? So I can actually make like the large language model like Llama 3.1. In this case, it's Llama 3.18b, and I can actually use it as my private Gen AI tool, right? So I can ask it some question, and it has the ability to respond. Yeah. So I don't know how you are using Gen AI today, but for me, I like to have a private, Gen AI that I can talk to, right? At least, especially on helpful on flights, right, where you don't have Wi-Fi access, right? So you can continue to program, ask it questions. It's just like your companion that can actually help improve your productivity. Okay, and the beauty in this demo is that it's actually running on Graviton CPU instances. So many customers have the misconception that I always need like GPU to actually make like Gen AI instances and inferencing workloads, but it all really depends on your use case, right? And sometimes lightweight CPUs it can actually be good enough for those use cases, right? So and you can also use it for your testing environment. So instead of running expensive GPUs, right, you leave those expensive GPUs for production when you really need the traffic. But for functional testing, you can actually test this Gen AI inferencing on CPUs for start. Okay, cool. So with that, I've come to the end of my session. So are there any questions? Yes.
What I take away from this is that Graviton is 20% cheaper.
Yeah.
And we're selling services to our customer, several databases in the cloud and also virtual machines, workspaces. If we migrate right away, we save millions of dollars. Right?
Yeah.
I mean, will this how will it play in the database space in the server, the virtual PCs, and in the workspace?
So your question is like, yeah, you have seen that it's effective on EC2, but how about the databases? Does it bring the similar benefits to database?
Yeah, that was my question.
Yeah.
My question: how will the database space benefit it, and then the other non-managed or the other server application that resides on virtual PCs?
On which PC?
Virtual machine. VMs.
VMs.
Yeah.
You mean like on-premise VMs or
on the cloud?
Oh, not on the cloud. like non-cloud virtual machines, like maybe VMware that's sitting in your data center?
Yeah.
Okay, yeah.
So the idea is right now we have several cloud infrastructure. So and we also have private cloud, and we're actually selling these services. So when I heard this is cheaper, we are interested in having a CPU because 20% is a big figure.
Yeah. And actually the savings can be more than 20%, right? Because with performance it goes up to 40% and even more. So look, thanks for those questions. So I'll address the database part first, right? So our managed instance like RDS, like managed database, already supports this Graviton instance, and it's easy to switch to them, right? So you can just go there, click a button, and then you will do a switch to Graviton. And once you switch to Graviton, the API remains the same, right? So you don't have to change your SQL query or syntax and things like that. But as to how much, it's definitely cheaper, but as to how much performance benefit you can get out of it for database, it all depends on your queries, right? So if your queries are very compute intensive, like a lot of joins, tables, and a lot of calculations, those tend to be more compute intensive, and they will benefit more from Graviton. But if they are more storage intensive, like your queries are always retrieving historical records, then those are more I/O intensive. So if that's the case, then the performance benefit may not be that much. Yeah. So that's for RDS, but you can certainly run Graviton to power your self-managed database like MongoDB, PostgreSQL, MySQL. Yeah. So all these will run well as well. Yeah. So as to your second question, like how can I enjoy this processor in on-premise data center VM? Like if it's running on VMware. So actually, of course, Graviton servers are only available on the cloud, right? But however, if you want them in your data center, we have an offering called Outpost, right? Where we manage the rack for you, we manage the hardware, and we ship it with Graviton processors as well. Or you can also like investigate the possibility of buying directly from Ampere Ultra, right? Some of these suppliers also supply ARM servers as well.
Oh.
Yeah.
So we can power our data center.
Yes, that's right. That's right. Yeah. Cool. Any other questions? Yeah. One more question. Yes.
If you're running for example, we have already the AMD 64 that we have in the node pool now.
Yeah.
And then if we integrate to the Graviton, because we are pushing it to the ARM base 64, or there's some mixed architecture in the Graviton.
So your question is you're running on AMD at the moment?
Yeah, AMD 64, and then maybe it will having a conflict for the ARM 64 for the binaries. So it's possible for the Graviton to have mixed architecture.
Okay. So is it possible to have mixed architecture, right? Is the service that you're running like EKS?
Yeah, EKS.
EKS, right? Yeah. So like what I shared earlier, you can run EKS cluster with x86 and ARM64 node group. Yeah. It's certainly possible. And then you can make use of things like node selectors, node affinity, things and tolerations. If you want that port to specifically go to one of the architecture. Yes, you can force it, or if you don't want to force it, it's fine. As long as you have built the multi-architecture container image, you can actually leave it to run anywhere. And if you are running it with Carpenter, right? Carpenter actually chooses the lowest cost deployment option for you. Yeah, so if you leave it to the decision of Carpenter, most of the time you end up running with Graviton instances. Okay. Okay, so I think the question is, what if you have architecture-specific binary, right? And do you build that binary in your Docker file? In your Docker file, right? So if you build that in your Docker file, if your binary, if your programming language can cross-compile, right, you can make use of the variables that I mentioned just now, like target OS and target arch, to make sure that these variables go into the cross-compilation. So the programming language like Golang, C, C++, all these will then generate the architecture-specific binary. Yeah. Yes, you will adjust it accordingly. Yeah. Thank you. Okay. If no other questions, I think we have a quiz coming up, right? Yeah. So, yeah, we have a quiz, and there'll be prizes to be won. So if you need the Wi-Fi, let me check the Wi-Fi first. Where is it now?
Cloud vouchers. Yes. Worth 70%.
Yeah.
50%.
So how do they get Wi-Fi? Wi-Fi?
Tatlong code cloud
It
and
will
then
be broken wires,
three voucher, 50%
2019
voucher for
password.
KCNA exam.
Can they use their mobile phone to take the quiz?
Yes. Yep.
Okay, okay.
Top 3 winners. Bali 6 winners in total. Okay. Yes.
So winners will receive Go Cloud vouchers and also discount vouchers for the exam. And we're also giving away universal cards.
Thank you, Wayne, for that amazing talk. Particularly the advancement in adoption of keystroke in ARM, because that's really a huge blocker for clusters. It's as Ortiz mentioned, adapting multi-architecture is impossible without that support. So now we're moving on to our quiz, but currently, as you know, it's our first K8SUG meetup, so we're actually looking for more volunteers or speakers or sponsors. So you can choose whichever you want to scan, or maybe all of them. So I'll give you some time to choose. Yeah. Yeah, we'll also post this. So here's our social media accounts. And here's a survey so that we can improve how we deliver our meetup continuously.
We have additional food later, so after the quiz, feel free to get pizza and pancit container.
Thanks, Nadine. And also, if you haven't registered yet, please go to that corner, because aside from the quiz prize, we also have some raffle prizes. So you can only win if you're registered. So please go there if you haven't registered. Okay, so now moving on, here's our prizes. So we're giving away 3 6-month cloud access for the top 3 scorers for our quiz. And another 15% of Kubernetes exam code vouchers for the top 4 to 6.
Donated by Romar. Donated by Romar.
Donated by Romar yung 50% of vouchers. So please thank him if you see him later. And so please scan this to please scan the QR code to access the quiz. So it will be asynchronous, but I'll also read along the questions. But if you already know the answer, you can move along faster.
Hindi na natin i-flash.
We cannot access.
Oh.
Start. Just a quick just some little bit of technical difficulties. Please bear with us, but you guys are excited, so just another reminder, it's asynchronous, so you don't have to wait for me while I'm reading the questions. If you already know the answer, you can move on to the next question because it's not only scoring you based on the right answer, but also the time you answer. So if you answer the question faster, you're gonna get a higher score. So don't wait for me.
Ito na lang.
Can you guys try this QR code? Thumbs up, please, if it's working. It's working.
Yun yung quiz ko.
Start mo din yung quiz.
Oh, na-start na lang.
I am flash mo.
Eh, meron lang na may join.
Okay. Yung question eh.
Hindi natin i-flash.
Hindi na. So, hindi ka na babasahin. Okay.
Okay, so we won't be flashing the questions na. So you guys can do the quiz on your own. So I'll just yap here while you're all answering. And I'll look for the person that's most suspicious. We're also flashing the leaderboard there. So Michael Lan, so we're the top one.
Hindi ko pa na-try. It's starting already. Pero they can take it.
Yeah, you need to be signed into ConHub to participate. If you haven't registered again, please go to this spot.
Nasa nag-start na. Unahan naman siya. Alam ko kasi when you join, parang pabilisan lang talaga siya.
Question 1. Which of these AWS instance is Graviton 3? Oh, yeah. 3 participants with the correct answer.
Teka lang.
So, it's okay if we flash the correct answer.
Ulitin na lang natin. We can restart na lang kasi not everyone has joined.
We'll wait for more participants to register then.
Okay.
It's just a dry run.
Ulitin na lang natin.
Okay,
Sorry, hindi ko
we have
kasi
one bonus question. If we dropped the answer. Yeah. Please log in first to your account so that when you scan the QR code later, it will be activated.
Sorry. Kasi restart. I think pwede naman.
Some of them expired already. What does that mean?
I think we can
we're restarting the quiz, so we'll give you another QR code.
I-reset na lang natin para start from beginning tayo.
Yeah, we'll start from scratch.
74 participants. So, do we wait for all of them to join or set a timer?
Can we release the QR code before starting the quiz? Or does that not work like that?
Hindi pa alam actually.
Okay.
Yeah, normally parang you can release the QR code
before the start,
and then wait for them to join, so everyone gives thumbs up or whatever, get majority thumbs up, and then you start the quiz.
For the meantime, please log in so that we can give a fair game for everybody. Because the account is required to start the quiz. So please log in your accounts.
Start na kasi ito eh. Okay.
Cloud Pro ba yun?
Sa ConHub.
VS Code
Yes.
Closure.
Alam mo to, Chris. Hindi ko ma-figure out paano ulit yung ipalabas yung QR.
Saan yung may start quiz?
Sa the quiz na yung start
Yes.
yung link.
Naka-start na siya or
Hindi pa.
No. So, parang everyone signs in
Okay.
they start.
Okay.
Yeah, we're sharing that QR code again, but we're not yet gonna start the quiz. So everybody just prepare
Dapat
yourself.
pala nag-dry run tayo.
We'll give you 5 minutes.
Yeah, so when everyone basically logs, like registers and is in, can you put your hands up so we know that everyone's okay? Okay.
Let's try reversing that. If you haven't logged in yet, please raise your hand. And if you're already done, please lower it so we know if we're still waiting for anybody. So if anybody's still not logged in, please raise your hand. One more here, one more there. Please keep raising your hand if you're not yet logged in.
Ay, sorry.
I'm assuming everyone here is done.
You can, extend
Everyone
it.
gets okay. What about here? Have you all guys logged in?
I don't know. So season
Ayan, naka-mirror kasi.
We just haven't started yet. We're waiting for everyone. So,
Ayan, okay.
anybody that's not yet logged in here?
Ano yung QR?
All good.
Ayan.
What about here? All good, guys.
There.
So all good.
I'll remove the camera.
Okay. That's better.
First time kasi namin sana pala sinabi.
Okay.
So, ngayon, paano natin
Or mukhang hindi lahat sa side.
39.
Mga hindi.
Okay.
Okay, we're gonna start the quiz now. So, go. First question. Yeah. Which of these AWS instance types is Graviton 3? Earlier we got 3 correct answers. Hopefully everyone now.
May free bonus question.
Wow. 37 correct answers now.
Need natin yung next question.
Okay, we're starting the next question now. Which of these processors below make use of hyper-threading? Ampere Altra, Intel, Graviton 3, or Graviton 2? Do we need to ask a friend? Where's Wayne? Correct answers. Bravo. Reminder again that you're not only scored on the correct answer, but the time you answer. So the faster you click the correct answer, you get higher scores. Which of the following does not help to assign a Kubernetes workload to be scheduled on ARM nodes? Dates and tolerations, node affinity, node selector, or node pool. Okay. Next question coming. Which of the following tools make use of emulator? Canico, Builda, Docker Buildex, or Podman? Oh, 34 correct answers. Next question. Which of the following CI tools does not have hosted ARM runners? Bitbucket pipelines, Docker Build Cloud, GitLab CI, or GitHub Actions? Oh, 41 correct answers. What is the Kubernetes object kind service used for? A kube service is utilized to replicate your pods. A kube service is leveraged to call AWS support service to your kube cluster. A kube service is used to expose your deployment replica set, or a kube service only functions as a load balancer for the pods. You can see our leaderboard moving fast because time is a huge factor for the score. So if you're pretty sure with your answer, just click it as fast as you can. Okay. Your senior software engineer was kidnapped by aliens last week. So this week you inherited the ownership of his or her Kubernetes cluster with almost zero documentation. While investigating the cluster, you notice pods increase in replica count automatically whenever they get busy, either by processing load or whatever. What's the most probable reason the pods increase in number automatically? Yeah, HPs are culprit for pod autoscale.
Ay, sorry. Mabilis ba? Mabilis ba? Sorry.
Which of the command you would use to gain logs from a specific pod in Kubernetes? kubectl logs, pod name, kubectl get logs, -f, pod name, kubectl logs, -f, pod name, kubectl log, pod name. Thank you for your answers. Good job, everyone. Last two questions. Which of the following is not a built-in Kubernetes resource type? Pod, daemon set, replica set, or load balancer? LD and LD is and the correct answer is load balancer. Usually service or ingress controller use a load balancer in cluster. Which of the following is likely cause of a crash loopback of error in Kubernetes pod?
Good job. 39 correct answers. So we have our top 3.
Picture na lang. Picture na lang.
So if your name is in the leaderboard, please come on front for us to take some leader pictures. So Renz Angelo, LP, Matthew, EJ Cortez, Neil Daryl Sulit, Jody Lemasi. Where's the other 3? If your name is in the top 6, please come on front. One more. Who's missing?
Nasa gitna.
Congratulations guys. So please reach out na lang for your prizes.
Tatabikin na lang.
Yeah, we have some raffle prizes pa. So
Para sa rapot. Ano, bali 5 AWS labs. Thank you ka na lang sa AWS.
So we're gonna be giving out 5 goodie bags from AWS. So thank you again, AWS. Thank Nadine for this. And don't forget that we have more food later, so more networking and food.
Kasha pa siya sa... Sama sila. Ayun.
So we'll be doing a wheel of fame for the raffle. Please come front na lang if your name is chosen. Yeah, so winner number 1. Winner number 2.
Not seeing that.
Tatlo pa. Congrats. Thank you.
Next winner. John Chadwick Romar. Last two. And our final winner for tonight. Michael Lance.